All right, welcome to the video on exponential equations, or in better terms here, let me put this up here. Give me a second. Solving exponential equations. Okay, so that's our goal here in this particular topic is we need to use these properties or exponents to solve these particular problems. Now, I made some clear points, and I also made this in different font here, is that first thing we need to do with these problems is to find a common base. Common base is very important. Now, with that said, we do not want to make a number different. Okay, so let me kind of talk about what that means to find a common base and what we're trying to accomplish here. And I'm going to use a very simple, just fraction example. Like if I were to say 1/2 plus 3/5. Now, 1/2 plus 3/5, in order to solve this fraction, we have to have a common denominator. In that case, this would become 5/10, and this would become 6/10. So my answer would again be 11/10. A simple problem dealing with fractions, but you can see why I bring up this example is that it shows you that although we may have changed the numbers, the value did not change. That is a key thing with these exponential equations, is that we are manipulating these numbers, but at no time are we ever going to change the value. All right, so let me work into this first problem right here, and this is a good example, a good one to start with, and this kind of these numbers go off of your paper that you're working off of, is if we look at this one and we want to find a common base, I noticed that, okay, I like the 3, I like the 9. Now, if I were to say, I'm going to change this to a 9, that's going to be a good common base. So I write this as 3 squared and negative n minus 2 equals 9. This would be wrong, okay? And the reason why is that I've changed the base 3 to 9. I've made it larger. I've changed the value. No longer, if I were to write this out back into its regular form, I'm not going to get the same exact problem here. I'm not going to get 3 squared is not 3. This is a completely different problem. So what we need to do is be able to change the base but without changing the value. And so if we look at this, we're going to keep the 3, negative n minus 2 equals, and instead of having 9, we can easily write 9 with the base 3 as 3 squared. And so once we get to this point, and we have these kind of tricks to help us kind of get to this point. So 1 through 4 here kind of help us to get to 5. Because our goal is to, if we have the same base, we then can set the exponents equal to each other, which is where our variable exists. So in this case, now that our bases are the same, we can simply just put the two the two exponents equal to each other and solve. So I'm kind of close on room here. I got negative n equals 4, so n equals negative 4 as my answer. So with that said, if you take a moment here and see if you can find the common base, or at least think of the common base that we could use for this particular equation. If you said 32, we do not want to use 32 because we're not going to write 64 as 32 times 2. Okay, although this is equivalent, we need to come up with things with the power. Okay, so we want to find a power of a number, but that would have the same base. So 32 times 2, although it has 32, we're not going to be multiplying. We've got to take everything to a power. Okay, so with that said, we can maybe look at 8, but I can't take 8 to a power to make 32. Can I take 4 to a power to make 32? Well, I got 4, 16, and then I have 64, so I skip over 32. So what I have to go to is kind of old faithful here, which is 2 to the 5th power would equal 32 to the 2x, and then also 2 to the 6th power equals negative x minus 3. So what I just did here is I just put these in brackets. 32 is the same as 2 to the 5th, and 64 is the same as 2 to the 6th. So my value has not changed. Now, like I mentioned earlier, we need to get to this last space. We need to find two bases with two exponents, either exponential functions, and we're going to set those equal to each other. So in this case, the reason why I put these in parentheses is we're going to use this particular one right here, and that we have a power to a power, so we're going to multiply those. And this is very important, is we are going to take 2, I'm going to have to write in some other areas here, 2 to the 5 times 2x, and this is also very important, 2 to the 6 negative x minus 3. So we put this whole exponential function in parentheses. And so what we're going to do is we're going to distribute that, and we're going to come up with, I'm trying to find a space. I'm going to go down here. Kind of jumbled space here. We have 2, 5, that would become 10x. My apologies. 10x. And this would become 2 to the negative 6 minus 18. 2 to the negative 6x minus 18. All right, so I'm at that goal. I'm at that step number 5 that I need to be at. And so now I'm going to set those two exponents equal to one another. And then I'm going to solve, obviously. I'm going to say plus 6x plus 6x, so I get 16x equals negative 18. If we divide by 16 and simplify, we get an answer of negative 9/8 as the value of x. So again, to recap that, I had to find a common base. These are rather large numbers, but they are multiples of 2. So 2 are a power of 2. So 2 to the 5th is 32, 2 to the 6th is 64. And this is a big thing when people make mistakes, is they forget that they have to distribute the 6 to all the terms in the sequence. All right. Now you're probably looking at number 24 and 23 and want me to get to those, but let me quickly look at number 17 here, where we have fractions involved. Now, personally, I don't mind fractions, but in this case, I'm going to kind of get rid of them right away, and I'm going to use step number 4 here by changing all powers to, or all numbers to a power. I can change it to its opposite by taking it to negative 1. So let me repeat that, or maybe I'll just show you and then we'll get to it. So we notice that 1/3, 3 on the bottom, but what I'm going to do is I'm going to change this whole problem around by just taking 81 to the negative 1, 2x minus 1 equals 3 to the negative 1, x plus 2. Okay, so what I just did is both of these numbers are the power of 1. If they don't have an exponent, they just are the power of 1. And so what I've done is I've just taken them out of the denominator's position and put it in the numerator's position. We can prove this by using patterns in the math, in patterns and showing how powers always divide by numbers. I think I've shown that graphic before online, or not online, but on the board. So now, with that said, even though this negative 1 is going to sit up here, we're going to still use base 3 for this particular problem. So I'm going to change 81 to 3 to the 3rd, but I'm going to use this negative. So I'm going to say 3 to the negative 3rd, 2x minus 1, equals 3 to the negative 1. That still stays negative 1, x plus 2. Now I'm going to go through this exact same process as I did with number 12. I'm going to distribute, and then I'm going to solve. Very, again, important that we distribute this negative 3 to all the terms in the exponent, not just the front term, which common mistake made. And if you solve this, you should get, I'm not going to do necessarily the linear algebra portion, but we should get an answer of 6/7 as your answer. So if you work that, go back and work it, you'll find out that the answer is 6/7. And if you didn't, make sure that we distributed to all the terms inside the sequence. All right, next one up here, we got the more kind of complex problem here. But I'm telling you, the only thing that's complex about it is that we have to incorporate steps 1 and 2. And you'll see how they're incorporated here very shortly. But don't let these things intimidate you. Okay, so let's kind of look at what it's going on here. First of all, we need to find a common base. So first thing, let's find a common base. In this case, this 2 is kind of giving me hints here. So I'm going to use 2 as my common base. So let's, first step is let's find that common base. That's 2 to the 3rd, 1 minus 3x. Then we have times. And I'm going to rewrite this in case we're still a little bit familiar with powers, negative powers, but it's best to just jump right into it. So 1/8 is the same as 2 to the negative 3. Again, 8 on the bottom, 2 to the 3rd is 8, but because I want to make it up on top, I'm going to put it as negative 3, and then we have 2 squared, which is already at the base we wanted. All right, so let's get crazy here. We have 2 to the third, 1 minus 3x times 2 to the negative 3 times 2 minus x equals 2 squared. Now we all have the common base here now, but before we start jumping in and start saying this, we're multiplying these two things. And some of you guys are seeing the writing on the wall here. But if you notice step number 1, or property number 1 that we've labeled here, that if we multiply two expressions with the same base, we add their exponents. So again, some of you guys are seeing the writing on the wall here. Let me write these as distributed. So we have 2, 3 minus 9x times 2, negative 6 minus, or this would be positive 3x equals 2 squared. And so you'll notice that what we're going to do is we are going to actually add these exponents. So we're going to add them. So we're going to have 3 minus 9x plus negative 6 plus 3x equals 2. Now what I just did was I know that these are going to, this particular expression, adding these two exponents is going to equal this one, which is going off of 5. So now we just have a linear equation on our hands where we just got to combine like terms. So we combine the 3 and the negative 6, so we get negative 3 minus 6x equals 2. And when you solve that, you should get an answer of x equals negative 5, 6. All right? So that's probably, we'll run into some different problems, but that's probably advanced as it gets. You might see some problems on there a little bit more, just kind of manipulating the functions, but I think you guys can handle it. On this last one, what we're going to be doing is dividing. Now it kind of gives it away as what our base is going to be. I'll kind of erase this here. So that was multiplying two exponential functions, and you can see here that we are actually dividing two exponential functions. I'll actually leave that up there for somebody who still needs to take notes. So we have 4 to the negative x divided by 4 squared equals 4 to the x power. Now all I'm going to do is follow property number 2 here, which states that if I have two properties, or if I have two exponential functions with the same base, I can subtract their exponents. Okay, so under one base I can subtract their exponents. So what I'm going to do here is I see this right here. They have the same base, so what I'm going to do is just write them with the same base but have negative x minus 2 equals 4x. And at this point in time, I'm in my comfort zone of pretty well understanding now that I can set these two equal to each other, and so you should get an answer of negative 1. Now the answer sheet to this paper is online, and so you can check it. You can also check it in class with the answer key available. But like I tell you most of the time, the best way to learn this stuff is to jump right in, learn from your mistakes, and work through it. So thank you very much, and have a fabulous weekend.